messed it up. I know why I messed it up now.
Okay, so you have a boat which is on the still water is 10 kilometer an hour, and the current is 5, and it go on the easterly directions. Right, so what you have in here is kind of like this. You have a boat, and then the river is going this way, which is a 5 kilometer an hour. And then the boat can go in, have to go in this way because eventually you want it to go that way, right? So, and you have a wind which is blowing at 8 kilometer an hour on the direction of south 30-degree west. So that means south 30-degree west is going to blow from here, like this. This is 30 degree. And the speed is 8 in here. Right. So the first thing I will do is, because the still water is going to be 10 kilometer per hour. And I do not know the angle, so I'm going to call this as an angle theta. And the aim is for the boat to go straight up this way. So I'm going to break everything into the component form. So the going straight up, this one, if you break it up, this is equal to just 5, 9. That's it. And this one, if I break it up, I'm going to have it as 10, and then you have sine, it's going to break up this way, going across, going up. Okay, so I'm going to have minus 10, then cos of theta I, plus it by 10, sine of theta j. That's what I'm going to get because going to the left, and then going up. And then the very last piece, which is the 18 here. Right, so that means if I break it up, it is going to go to the right and then going up. So that part is going to be 8. And if I use a 30, the one that is going to the right is going to be a cos 30 degree I, and then plus it by 8. This is a sine, sorry. Going across is a sine. Because you go, it's here. And then this is a cos 30 degree j. Yeah. Right, the resultant, you want the resultant to be going up. That means the horizontal is going to be 0. So let's add up all the horizontal. Here the horizontal will be this, and that. Let's add it up, and you should equal to 0. So you have 5 plus it by 8 sine 30 degree minus 10 cos theta should equal to 0. And sine 30 is going to be a half. This is going to equal to 4. So you have 9 minus 10 cos theta equal to 0. And therefore your cos theta equal to 9 or 10. And you're able to find out the theta. So that will be your angle that you should be traveling. Does it make sense? Yes, interpret it. So your aim is you have three different what is that, velocity. Put them all in one and think of it as a component form all the time. Yes.
So you're adding up everything together.
Yes, I adding up what I did is I adding up all the horizontal. So at the moment I don't even look at the vertical because the boat is eventually is going to go straight. That is our aim.
Okay.
That means what I have for the angle going up, that means my horizontal has to be 0. That's why I say if I add up all the horizontal, it becomes 0. Yes. If I do the vertical, what will happen is that these two angles, when you add it up, it should equal to what should this equal to? Equal to a number. No, I can't use the vertical. I have to use the horizontal because you have no horizontal direction. Your resultant doesn't have horizontal anymore. Because as you go up this way, you only have something with the j. You got no I because the thing is going up. So you have 0I plus something j. Yeah, does it make sense? Yeah. Okay, so now that means I'm able to find out what is the angle theta equal to. If you know the theta, that means you put it back into the vertical. The vertical is going to be these two terms in here. You only have two vertical. So if I add it up, I'm going to have 10 sine of theta plus it by 8 cos of 30 degrees. So if I know cos theta equal to 8 on 9, that means I can draw my triangle. Cos theta is 9 on 10, okay, 9 on 10, so 100 minus, so it will be 19, right? Yeah, that will be that. So sine theta is going to be root 19 on 10. So we are going to have root 19 on 10 plus it by 8 on root 3 on 2. Yeah. So you have root 19 plus it by 4 root 3. That is going to be the speed, if you want to, of the boat going. Yes. And what is that going to give you? Give us a slap first.
11.29.
Is that what you get?
No.
No.
But I did it completely differently. I don't think it worked.
So does it make sense for these type of questions? Yeah. So the idea of any boat or plane, it fly, you have multiple wind come from everywhere. What you do is break every single part into component form. And then the vertical and the horizontal, break them up as well. And in this question, because the aim is moving north, that means my horizontal is going to be 0. That's how I get the theta from. Oh, good.
I think so.
Yes, you think so? Okay, then that is the first part of the question, right? What sailing direction should the boat be steered at in order to, yep. So, what direction? Actually, you are only looking for this. They don't ask you the speed, they only ask you the directions.
Oh, it does ask you for the speed as well.
It does? Oh, find the resultant speed, yes, it does.
Can I just take a picture of this and then
Yes.
redo it so that I can
Yes.
make sure I can...
Yeah, definitely. This is really important. All the question is going to look like this all the time. Okay, you are going to have multiple forces coming along and then break it up. Right, then the second part of the question say, now the boat is traveling at 10 kilometers an hour. And the question is asking you to see whether it can be decreased. Will you still reach the north? Right, so thinking about the angle. Angle, that means you're looking at this thing in here. And what we know about this thing is that cos inverse of a value, that value cannot be bigger than 1. Yes, so if I decrease the 10, the most I can decrease is decrease to 9. If I decrease to 8, that means it's going to be undefined. Yes, so yes, the question is, yes, you can decrease it, but how much can you decrease it? You can only decrease up from 10 to 9. Anything between, you're still able to find the answer. Anything below 8, 9, there's no solution at all. It's going to be blown away. Does it make sense at all?
Yes.
Yes, because of these equations in here. That is the second part of the question, part 1, the question B of part 1. Yeah, because now what they are asking is like, if you keep changing this number, yes, what will happen? Yes, the angle is going to work all the time unless this number is less than 9. If when it is less than 9, it's not going to give you any solution at all.
So you just say the minimum
now?
9, and that's because cos theta cannot be greater than
Cos,
1.
cos theta, cos inverse of
Of
this
the-
number.
oh,
Yes,
okay.
cannot be greater than 1. Yeah. Okay. Makes sense, right?
Yes.
Yes. How much you need to write, I'm not sure because there is
I
no
don't
marking
know
guideline
either.
in
Oh,
here.
there is now.
There
I
is
think.
now? Oh, but
But it doesn't say
No.
anything.
It
It
doesn't
just,
say-
it's just a bunch of random words.
No, it doesn't mean
Yeah.
much. Yeah, that one doesn't mean much in here. It's very open. I'm not sure how much you need to write. Right. Then let's look at part 2. Part 2 is something that I'm not too sure what you should be doing, but I will just guess, okay? Okay, this one is all done? Right. Okay, part 2. Lucy, I give you a minute to read through what you want.
I have an answer for part, like the A,
Mm.
but then everything else I just didn't know. Yeah, because the only equilibrium problem that was in like the textbook
Mm.
that we ever did was this one. And when I drew it out, I'd get 40
Oh.
degrees and 70 degrees.
I
don't think it
wasn't
works.
guessing of this one. I was guessing.
It is,
really
yeah, maybe
guessing.
it's something like you have that and like forces acting on it. Yeah,
Yes.
that's what I was thinking as well.
Mm,
But
mm.
also,
Yeah. Right. So I will be thinking of that one. The one that is sensitive. Okay. For example, if I have a point, okay, or something, whatever you want to call it, a force pulling it this way, and what is the number you want? Just random. Doesn't matter.
4.
4. Yes. Okay, and then you have another one going this way. Maybe they say measure it using. They want you to measure, right? Something
Yeah,
to do with
they want you to
measurements.
use like actual like,
So if this is a 4, let's put this as a 2. Yes, 4 centimeter, 2 centimeters. Okay, so that means you are going to have another force that might be going this way, isn't it? I'm not sure where it is. So the one that they need to do is they need to measure using a proper scale. So if this is a 4 centimeter, this is a 2 centimeter, and this one is going to end up being something that I do not know what is it at the moment. Right. So let's create the angle 2. So let's say if this angle in here is 100 degree, and this one in here may be, what is this one look
So
like?
do you create the angle or do you measure it?
You can measure it. Yes, you have to measure it. In
Yeah,
your case, it's
yeah,
measure
okay.
it. Yes, you can't create. The first angle you kind of can create it, can't you?
I don't know.
Yeah, you have to. Because what happened in here is that if that is my 4 centimeter, this is my 2, that means this one in here, whatever angle okay, so we need to do both at the same time here. Okay, I'm going to first thing break, okay, so I think of that as a 100. Because I haven't decided what is this force yet.
Oh, okay.
Yes, I haven't decided. So I say,
But-
okay, this is, yep.
Then wouldn't you create the other angle and not?
Oh, any angle.
Okay.
Any one of them. So if I say this is 100 and this one is less than 180, right? So this 110, let's make it a bit bigger. 110. And this one is 100. Okay, let's keep it that way.
Okay.
So now if I break it, draw a line across. So this is 110, that means this angle in here has to be 70.
The other one's 40.
This is 30, right? 30?
Yeah.
Yeah.
Wait, why? Oh, yeah.
Yeah. Okay. 30 degree, and that means this angle in here has to be 150. Is that all good?
Okay. So you just
Yes.
decided on an angle. Okay. Because otherwise
Yeah, otherwise
Okay.
we can't.
it doesn't
Now
make sense.
I can put that into the triangle. That's what they want you to do. So the 4 is right here. This line is that one. And then let's change it into different color. So that one is the green. Going this way. So you know this line is there. The green is going to come in follow on from here, isn't it? Yes. So that means this angle has to be 70. So I know this is 70. This is my green. And this is my black. Goes that way. And then this one is going down, which is, let's call it that way, which is going down this way. Yes. So if you have this as a, okay, measure it nicely. This is a 4 centimeter, 4 Newton, and this is 2 Newton. Then, because you know that means you're able to find this one. Yes. Or maybe we should make it a bit nicer to work with. Cosine, let's make this into 60.
Okay.
Yeah.
But I mean, you'd have to measure it anyways.
Yeah, if you have it at 60, then we have a nice
It works
number.
better,
Yeah, so let's make it into 60 so we can have a nice number.
Okay.
Right, so in the popular question in here, maybe this one keep what? How can I make it into 60?
120.
120? Yeah, that will work, isn't it? 120, that means this is going to be 80.
60.
60? Yeah, I can't count. And that means this one is going to be 40. Yep, and that means this is going to be 140. Yeah, let's make it into that way. So you have a nicer number. Right, then you measure, then you have this one is going down, going up. Yep, so this is the first section of the question, I think. You need to measure it.
Yeah.
And then it comes into the funny questions. Why is it a triangle? Why the triangle end up to 0, isn't it? Equilibrium.
Yeah,
Because
it'll end up having to have 0 displacement because equal.
Yes, something like
That
that.
I get.
Yeah, okay.
And it says repeated for a number of different questions, and then it's like, how many different types of questions are?
Okay, which one is that? What is it?
Part 2C.
Part
Just
2.
repeat this technique for a number of different questions.
Oh.
So does that just mean that we need to like do it for like different numbers?
Different numbers, or maybe a bit more branches?
I don't
Maybe
know.
extra branch?
Because a lot of my friends haven't started yet, so
Yes, I know.
can't really. ask them.
It's really open and ambiguous. Yeah. 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 That's what you do. Yeah, that's it. And technique, different questions. And I'm sure in the exam, instead of giving you as a measurements, and then they want you to do a conclusion, what's it end up being, is that like any force is given to you, you do not need the number, you do not need to measure it. What you are going to do is like do this. Change the angle from the angle, and then you work out what it is. Right now, what you have in here is that you are going from here to that. Actually, the real question is always go from here to that.
Yeah. Okay. So.
Yes, then you are using the cosine rule, isn't it, to find out what is the
Okay. I'll ask my friends what they do it.
Assignment is always really time-consuming, frustrating.
I wish they just give like actual like problems.
No, they never did to do that. The only school that I see they give you just problem is Norman Hurst. That is the only school they give you a proper exam questions to work at home.
Assignment?
The rest of the school actually you are going to deal with quite a lot of this. Sometimes you even have if you do data, you have to search up for the data, and then you have to do the Excel. If you are not good at it, that means you are hitting the wall all the time. It's quite frustrating. They expect everyone is a technical geek.
Yeah.
If you are not, it's really, really frustrating, especially like me. I'm not computer geek at all. When I touch a computer, it's like, interesting, but what? It's totally different view. Maybe for you guys, like, yeah, used to having the computer and all those things.
I can't use
But for me, it's like, really, really hard. Right. We are going to look at this sketching. Okay. Sketching. Okay, the first rule I want you to remember is that all the dilations you have, you are doing transformation. You have two types. Either it's dilation. Dilation, that means you are going to pull it up, down, or left, right. Translations, that means you are moving to the left, moving up or down, or to the, yeah, that is
When you say pulling up and
up and
so
down.
does that mean like making it thinner?
Stretching. Yeah, stretching
Okay.
it. So when I pull up, pulling it vertically, that means I keep this line as my balance. So if I have a curve that is going this way, When I pull it, what will happen is that these 2 points stay the same. If I want to pull it twice, double. So what I will do is, whatever this distance is, it's going to double up. This point, if you're thinking this is a distance, it double up. So if this is a point, I double this distance. So I will have those 3 points go down like this. Can you see that squeeze up? Yes. If I put it upward, which is horizontally, what I do is that I keep anything on the y-axis stay. Then I stretch it up. This is my balance line. I stretch it this way. So this one actually is that far away. Now it's double up. So it's going to be here. This one is at the moment is so far away, so it becomes here. And this point, thinking about where is it from here, I double it, so it becomes right there. Can you roughly see it? So I'm going to be able to see my graph. Oops, I overshoot. Going that way. Can you see actually this one is pulling up from here? Yes. When you pull across, remember the y-axis is the point that doesn't touch, doesn't change. When you pull it like this, the x-axis is the one that doesn't change. Okay. Okay. When you go across like this, we call it horizontal dilations. Okay. And be really careful. Another word is that horizontal dilations is the same as when you dilate it horizontally. You dilate it horizontally, you mean this way. And if I dilate the equations from the y-axis, okay, dilated from the y-axis, that means I'm still doing this one. If I dilate it from the x-axis, that means you're doing this. That is called vertical dilations. Okay, right. So the basic equations, if I've given you y equal to, okay, all the factor of dilations should be go under the terms. For example, this one, if I have y equal to 3x squared, I'm not going to read it like this. The 3 shouldn't be in here. When I read it, I look at it like this. This is my equations. My y have a 3 on it. This is my factor of dilations. So that means if my factor is 3, that means what I do is I stretch it up with the y like this. So that means this is the vertical dilations. Factor of 3. On the other hand, if I have y equal to x on 4 to the power 2. So this means I have a horizontal dilation factor of 4. So that means when you have the y equal to x squared, you pull it across by 4. And be really careful. This one, if I have put it like this, so I want to keep it inside. So this one is horizontal dilation factor of a half, because I'm thinking of it as the factor is always the number underneath the value, the x or the y. Okay? Right, does it make sense? So this is your dilations, and then I'm going to open up the one that you have. Oh, actually I have a copy of this. Right, so that is the dilations. Don't worry about in here I talk about a lot about where it is, but everything should be explained here. Everything in the box. Okay? Right, now if you're looking at question 1, I want you to write down the new equations. That one, dilated vertically by 2. So when you dilate it vertically by 2, that means you do it this way. So that means the 2, where should I write the 2? Under the y. That's right. So you're going to write it like this. Okay, that looks like a funny equation, isn't it? We don't normally write it that way. And you're thinking about it like this. So now, if you are sketching it, that means you are going to have it as y equal to 3 to the power x. Look like that. This is your 3. Oh, this is your 1, not 3. Then you dilate vertically factor of 2. So that means you stretch everything up by 2. So gaps from the x-axis, double it. any gaps in here, you're thinking of you're doubling it. So it's going to be here. Even though this little point in here is going to double up, it's going to be in there. So what it means by the 2, factor of 2, that means you pull everything up by 2. So it's going to eventually still really close to here, except go up that way. Does it make sense? Yeah. So dilate vertically, that means you're pulling up. Good? Okay. Now, let's look at question 2. You are going to dilate horizontally by factor of -2. Horizontal dilations, that means I put the dilation under the x. So you are going to have an equation y equal to x squared plus 2. Your horizontal dilation is -2, so I put it here. I don't worry about what it looks like. I don't even want to think about what this looks like. I'm just putting the equation in. So if you're simplifying it, so you're going to have x squared on 4 plus 2. Is that right? Yeah, so that is your equation of dilations. And if you need to graph it, then you graph it from the beginning in here. This is the original graph. X squared plus 2. So that means you have a 2 in here. Okay, horizontal with the negative in here. The horizontal with the negative, that means what you are going to do is you are going to flip it that way. Does it make any difference when I flip it that way? No, it's still exactly the same. And then you are going to stretch it up by 2. That is what it means by -2. -2 means you're flipping left to right, and then you stretch it up. So the balance point is this one doesn't move. Everything go double the size. This is where you are. Right now you are there. Make sense? Yeah. Okay, please don't get confused when your teachers start talking about the A thing in the front page. If you see the front page, I have that A thing, don't get confused by that, okay? Don't come back and say like, I get confused and do not know where do I move it. Yes, because the A thing get really, really confused. Right, now if you look at question 3, what will you do? Stick to our rules of vertical dilations. That means the factor go under the y. Horizontal dilation, the factor go under the x. That's what you do. Okay, you have dilated vertically by 3, vertical by 3, so I put it here. Horizontal by 3, so I put it there. So that means it means this thing, isn't it? Because the square is outside. I just put under the x, under the y. So if you expand it, and then of course you can times it by 9, and you can see what your equation looks like, isn't it? Yes, even from the sketching itself. Circle of radius 1 to start with. If you stretch it up by 3, stretch it up by 3. Of course, it's going to be a circle of radius 3 from there. And then the next one, you are going to have the dilated horizontally by a half. Where should you put the half?
Under the x.
Under the x, of course, yes. So you are going to have y equal to, y equal to x over a half, right? Yes, and then x over a half is a bit funny. That means it's equal to 2x. Y equal to cos 2x. And that is your equations. the normal cost curve, you can sketch it. It's going to look like this, going down and going up. I'm going to just sketch one loop. And now, if you horizontal dilations by a half, that means you squeeze everything in, isn't it? Horizontal dilation, that means a half. Oh, I did not mention about a half. 1, that means stay. When it is 2, you pull it up by 2. When it's a half, you squeeze it in by a half. Right, let's squeeze them all. So this point become there, this point halfway, halfway, halfway. This one is, so far, now it's going to be, what am I doing? Wait a second. Halfway in, and then halfway in. It should be in here. I'm not doing it right? This point halfway is here. This point halfway is a bit over here. This will be somewhere in here. This one will be halfway in here. Yes. So this point doesn't change. So you are going to have the whole thing got squeezed in by a half. And that means you know cosine is going to repeat itself. So you are going to have another one. Yeah, this is when you have another one. It's coming from here. Got squeezed in again. Alright, does it make sense? Okay, so always remember horizontal dilations, put it under the x, vertical dilation, put it under the y. Horizontal, that means left and right, vertical up and down. That's that. Okay, right. The next one is going to be similar. I let you try it at home. How does that sound? Yeah. Okay, let's see for the next page. Okay, maybe just do maybe one question C and D. Yeah, question 6, C and D. So if you want to dilate it horizontally, factor of minus a half. Yeah, and then vertically, factor of minus 3. Yes. Then expand it one more time. It's going to be 4. Yes, that's right. And the next one. Okay, sure you can do the sketching. That's all right. Horizontal, the negative means you flip it this way first. It doesn't change, and then you squeeze it in, right? Okay.
And this one you flip it on the y-axis instead.
Yes, that one. Maybe sketch D. Let's try to sketch the D. Yeah.
So basically just
Yeah.
sketch that graph instead of the
Yes.
original graph.
Yes.
That's complicated. Okay.
It's going to be pretty easy. You understand the concept, everything turned out to be just following the rules. So then you flip it upside down because of the negative this way. And then you have, because of the 3, factor of 3, that means you stretch it, it becomes really thin and upside down. Yes. Ooh, you do it wrong around.
Oh.
This one, it should be very thin.
Oh, should be.
Yeah, because the factor is 3, that means you pull it down by 3 times faster.
Oh.
Yes.
Okay.
You're not stretching to the side.
Okay.
That's why I don't want you to look at it
Look
as
at that.
yes. Don't
Okay.
look at that. You know it's vertical dilation. That means you pull it up and down.
So it's like, okay.
Yes, it's going to be really, really thin. Yeah. Yes, the original one look like that. All good?
But if you just put this into Desmos, would it give you this one or this one?
It will give you. You mean this equation?
Yeah.
Linear? It will give you this one.
Okay.
Yes. It's really, really thin.
Okay.
Yes, because it's 3 times thinner than the usual.
Okay.
The bigger the number, the
It's,
thinner they
oh,
are.
yeah.
Okay.
Yes. So
Right.
they're all faster.
Yes. And then the next one, let's try the middle 2 question, one horizontal, one vertical. The B and the C. Okay, so you have the equation x minus 1, x plus 2. So the first one, horizontal dilation factor of minus a half. X over minus a half. Okay, so for the first one where you have a vertical dilations, horizontal dilations, yeah. So what do you do first? Because it's just a minus, that means the first step is flip them, is that right? So if I flip them, so this point become a 2, that point become a 1. So it's going to be go this way. Yes, so at the moment if I flip it, it's going to go that way. 1, 2, and minus 1. Then you dilate it by a factor of a half. That means you squeeze it in. So the only point that doesn't change is this point. This point I should have to cross it, but not really. Squeeze it in by halfway. So that means it's going to squeeze in here. Halfway is going to be there. And this point is going to squeeze in into here, halfway. So I have 1 point, 2 point, 3 point, 4 point. So join up. So if you look at the equation you sketch, you already work out. It's not that easy to sketch, isn't it? But if you look at just the way how it being dilated, it's so much easier to sketch. You have a minus, flip it, a half, squeeze it in. That's it. Okay, let's try with question C. Now, question C is talking about vertical dilations. So vertical with minus, that means you flip it upside down. And then the factor is 2. That means you are going to put it tall, really tall. Oh, you are factor a half. You are going to factor of minus 2 vertical here this way.
So this,
Yes.
oh, so this will be higher. No?
Yeah, it's going to be this point in here is going to double.
Okay.
Yes.
All
Oh,
the way
this
up.
point doesn't change. You're pulling, okay? So first step, you have it upside down.
Oh,
So,
okay.
you
Yeah.
have get that? Okay, first step, negative, upside down. So I'm going to have a curve going upside down, like this. Then, you are going to pull it. When you pull it, keep these 2 points fixed. Have a nail on it. Now you are pulling the elastic up and down, double it. Stay, pull it down. So you are going to have it at this point in here, maybe right in here. So it's going to go up like this. Make sense?
Okay.
Yeah. Always remember when you put it vertical, the 2 on the horizontal stay. Okay, and then the next page is just stretching it according to what you have. Okay, so you are going to tell yourself what type of dilation is that happening in here. So for question 8, number 1, you have y equal to 2x. You come from y equal to x. 2x? What type of dilation is that? I can write as y equal to x over a half. That means it's horizontal dilation, factor of a half. Horizontal, that means I'm going to do this. And then I'm going to squeeze it in by a half. So every point, squeeze it in. Squeeze in halfway. This point in here become halfway. That point become there. Yep. So we are going to have this point become there. So we are going to join it up. Don't squeeze the up and down, just squeeze it in from the side. Yes. And then the second one is squeeze. Where should the 2 go? The 2 should go under the y, good. So because you have y equal to 2f of x. So that means you have y on 2 equal to f of x. So that means you are going to factor of 2, right? So pull it out. So pull. When you pull it up, remember the stay, and then the rest go up double. So instead of having it at 1, now you have it at 2. And this one, instead of having it at 1, oh my 1 and 2 is so far apart. Okay, the b number 1, what happened? What's the factor? 2. So that means you're pulling it, yes, outward. Good, good. And then let you finish that one first. Yeah. Yes. It's 2, that point stick. Yes. Good, good. Yes. This one is going to pull up. It's in here. Yes. Yes, that's right. Good. Stretch out. Really, really wide. Okay, and then the second part, where you are going to have factor of
What shrink?
string. Yes, vertical dilation factor of a half. So it's string down. The whole thing becomes really short.
And it stays.
Dilation of
Yes.
half. Oh, because you're
Yes.
dividing it by a half.
Y over a half. Good. We always want it under the one.
Okay.
Yes, not next to it, not anywhere else. So the
It's
stay
good,
point, this one is stay, good.
It
Yeah,
stays.
and this one go halfway down. So
Ah.
yes, you go too low.
Yeah.
Otherwise you're right. Yep. Okay, and one more mistake in here. This line should be under because you're
Ah.
shrinking.
All right.
Yes. Yes, that is right. You're shrinking halfway. Everything. Under. Good, good. Yeah.
I should get different color pens.
Yes. Yes. Okay, get the hang of it. Okay, so first thing, make sure you put the dilation on the right spot with under the x or under the y. Do not leave it as next to the x, especially the one with the x. Okay, you don't want to be next to the x. If I have 2x means x over a half. Okay, then you'll be good. Right, then the next question I let you try at home. Now let's look at the next page.
Yay. I love graphics.
Yes, it's all about graphing. Right, so let's look at question 9. So you are having, I give you a point, okay? So this is the question. I do have more on that. Right, so I given you y equal to f of x. I don't even give you the equation anymore. So I say there's a point A minus 2, 5 is go under the transformation of this. Right, that is the transformations. Now, what I want you to do not look at this as a point. I want to look at it as an x, as a y, because that's what we are talking about. We're talking about the x and the y. So when you are talking about the x, this is what you're looking at. Yeah. Talking about the y, this is what you're looking at. Right. So the x starts from minus 2. and plus 3. Remember which way we move it when you have x plus 3?
Minus,
Left by 3. So if I move left by 3, what are you going to get?
minus 5.
None. Your new a is at minus 5. Okay, then we do the same thing with the y, which is 5. Now this one ignore. So literally you means y on 2, is that right? That means factor of 2. What do you do factor of 2? That means you pull it that way. Yes, so 5, if you want to pull it that way, what will happen? Become
10.
10. You times it by 2. So your new a come up. Minus 5, 10. One thing not to do not look at it as one point. They are separate. X is here, y is there. Okay, after you do that questions, I want you to turn to page 7. Look at question 16. That is the next question I want to work on.
Which question?
Question 16. Page 7, the last question on page 7. Okay, I want you to do the same thing. So you have another point A, 5 minus 18, under different transformations.
Which questions?
Question 16, probably the last one.
What happens to the minus 1?
Minus 1, that is outside of the fx, right? That means that's a y.
Oh.
Okay, so you have a 5, and then you have minus 18. So y equal to the third f of 2x minus 1. Okay, let's look at the x first. What will happen to the x? Can you tell me?
Half.
Half.
Oh.
Half.
Half.
Don't do double. It's half. Good job. So you're thinking of it. This is what you're thinking. F of x over a half. So you need to times it by a half, right? So your 5, go times it by a half, you get 5 on 2. This is your new x. Then let's look at the y. Ignore this part. Where should this go? This one should go under.
Wait, so you basically just sub in the value after you put it under.
Put it under. What do you mean? Sub in.
Like, it becomes this afterwards, right? Do you just sub in y into
Sub in.
there?
I normally
And
do
you-
not do that. In some, I'm not sure whether x you can do that or y you can do that, but normally I don't.
Okay.
I don't.
Okay.
Yes, you can sub in the number for
Do
the
you
y. I think
just divide it by 3?
I'm going to times it by a third.
Okay.
Yeah, I don't care what is the number because it goes down like this, right? So you always times it by this number. Remember when you have y on 2, you times it by 2. Remember the 5 become 10. Yes, you times it by a third, that means you divide it by 3. Yes, you are right, but I'm going to just
Yeah.
think of it as a chance. Done.
Yes.
One rules rule them all. So minus 18, you times it by a third. So become negative 6. And then you
You
Move it.
right?
no, this is
Down.
down.
Oh.
Yes,
down.
the normal
Ah.
down. So you minus 1 again. So become
Oh.
yes, this is what you do. Yeah. If you get the hang of it, it's kind of fun.
But it like breaks everything.
Yeah.
You learn.
Yes, you are breaking the equation. Yes, you are trying to
You have to ignore equations as a whole.
yes. You look at x as a x, look at y as a y. You do not look at them as an equation anymore. Yes, they are no longer equations.
Okay.
Alright, so let's try again with the second question. Question B, the x. What will happen to the x? What is the factor?
Times it by 3.
Yes, times it by 3 because that is your factor. Yes, times it by 3, so it becomes 15. And let's look at the y now. This whole thing need to go down, right? The factor is minus. What happened to the minus?
It flips it.
Flip it. Yes. So this number, if it is a minus, become from minus 18 become positive 18. So because of the minus, I become 18. the 2
times.
times by 2. That's it. That's the rule. Times. We keep timesing.
All the people who are good at equations are now going to be terrible at this.
Yeah. Oh, good.
Yes.
Yes, this is what you do.
Oh, good.
Vector of dilation, you do the timesing. Okay, try the next one. Is get a bit more complex now. So this will be your typical exam questions this time, where they ask you to transform a particular point to somewhere else. Okay, for this one, your x doesn't have dilation, right? So what does the minus 5 mean? When you have x minus 5, you move
To
the
the
curve.
right.
Yes,
6 plus 5.
yes, that's right. Move to the right. Good. So you become a 10, right? And
And then you times the y by 3 on 2.
exactly. So you have minus 18 times by 3 on 2, then
And you add
add 4. Good. Yes.
4.
You times it by the dilations, and then you do the transformations. Okay, the next one. Next one is the one that is a bit tricky. You need to come into the next rule that I haven't mentioned at all in here. The y should be okay, just the x becomes a bit tricky. Right. So the x, what we need to think of is this
One,
number
four.
is always need to be 1 in there.
Oh.
Yes, you need to pull out the factor of dilations. Yeah. So that means it's kind of like I'm thinking of it as if I have 4 x minus 2 and then plus 7.
Okay.
So my factor of horizontal dilation is
It's half.
A quarter.
yes,
Ah.
because you're thinking if I'm writing an f of 4x. You know this part?
Okay.
Yes. So the factor is a quarter.
But you just added by 2 instead of 8.
Yes, then you add 2. That's right. So that means what you do is the factor is x over a quarter, right? So times this by a quarter, and then you plus 2 to it. Yes. So the number 5 times it by a quarter, then you plus 2. That is going to be our new x. Okay. The y, you can tell me what to do. Y
Times negative 3.
times negative 3 if you want to. Yes. And then
Add 7.
yes. Yes.
Okay.
Okay, just be really careful, super careful with this one.
Mm.
Yeah. So if I have a factor, so far it hasn't asked you much on the question, so far I haven't seen it like 3x minus 8. If I even have a question like that, I still factor the 3 up. So I will have f of 3x minus 8 on 3. So the factor of dilation is a third, then you add 8 on 3. Yes, always remember that one. Okay, then you are good.
Okay.
Okay, so few points to remember, keep a note for yourself, you should remember that. Okay, now go back to question 10, the previous page again. Right, this one is by looking at the equation, how the equation changed from the left equation to the right equations. What had it been done? What is being applied? So for example, question A, you have x squared minus 2x. You have 3x squared minus 6x. That means you times it by 3 to 8, isn't it? So you times it by 3. That means you have 3 of the 3 actually belong to yeah. So that means
vertical
dilation factor of
factor
3.
3. Yes, that is what has been done on that equations. B. A half. Yes, on x, right? Yes, literally means x over half. So that means is horizontal dilation factor of a half. Yeah, because you haven't learned any of these in year 9 and year 10. Now the new year 9 and year 10, they start learning this.
Oh.
Yes.
So it's a new syllabus?
Yes, but you guys are following the old syllabus. In the
Yeah.
start, it becomes a new
When
syllabus.
did they start this syllabus?
Year 9.
No, as in like for
this year.
when this year was when they introduced this?
Yes, this year year 9 start learning this.
Oh no, as in like when did they introduce
Oh, the
this?
new syllabus.
The new syllabus?
Year 2000 is the first HSC, so 1999.
Hmm?
Year 2000. Year 2020.
Oh,
Yes.
okay. I
I'm 20 years ahead. You are not born yet. yes. So it's what is it? 2019 is the first year they introduced the new syllabus.
Ah, okay.
So that is when they changed the younger syllabus as well.
Yeah.
So this year, year 9 is the first year they learn this one in year 9.
Ah.
Yes, your sister is learning this.
Haha. Idiot.
Yeah. We just gone through this part like two weeks ago.
Well, I guess we're learning it together now.
Yeah.
You guys can
But-
help each other.
But you haven't learned it yet.
Yeah, he won't learn it until
Next year because he already missed out the new syllabus. Yeah, it's really interesting how they change it.
Your
And
younger
that's not-
sister can tutor your older.
older. Yeah.
Yeah,
Yeah.
that's
Yeah.
true. That is true. Yes. Right. So that is then the next one. What do you think? Next one should be really straightforward. Yeah. Yeah, it's just a straightforward one. The next two is fine. Right. Then right. Okay, I will let you continue on that part at home. Then right. Should we look at question 11? It's a really wordy one, but it's not hard.
What is this from the y-axis?
Aha, that's the one I tried to trick it. Good, that you pick up. From the y-axis. What name does that mean?
Vertical.
From.
Horizontal.
Yes, from.
Oh, from this axis.
Yes.
So you pull it out that
Yes,
way.
and if I say with the y-axis,
Oh, okay.
with,
Uh-oh.
English come in.
Yay.
From. Yes, it
Yeah.
makes sense, right?
Yeah.
So this one means horizontal dilations, factor of a half. So that means you are going to put the half under the x, right? Yes, so you are going to have a half first. And then vertical dilations of -2.
So,
Translation of to the positive direction. So that means moving to the right by 3.
Moving to the translate 3 unit to the positive direction, moving to the right, that means it's going to be x -3. Yes. So far you have it as x. From the y-axis over half, and then you have it -2 in here.
Do we have to bring out the 2?
Bring out the 2, you mean the 2 in the front? This one?
Yeah.
Yes. So you are going to have
2x
more like 2
2
and then
of
x
minus
minus,
2.
yes,
minus
-3.
Ah.
Yes. Yeah, that's what you're going to have.
So it's not outside, it's in
Mm.
-3?
Yes.
Okay.
Yeah, that's what you do. Alright? Not that bad. Yeah, as long as you break it down into the x and the y.
So gx is equal to negative 2x.
Yes. There's your gx. Okay, now we are going to have more complex description of the translations, which is on the question 12 to 15. Okay, the 12 one should be quite straightforward. You have it as, what is your 2 dilation you have?
Vertically.
Vertical is A half, good. Horizontal is?
A third.
Yes. A third. Horizontal dilation, factor of a third. Vertical dilation, factor of a half. Okay. If you have a dilations and you have translations, make sure you write the dilation first before the translations. Dilation right first before the translation.
Do you just put it on like multiple lines?
Yes, dot point. Yeah, you can put it as a dot point. Okay, that one. Do you want to talk about vertical or horizontal? For question 13.
Wait, so you put, would you, if it had dilation and translation, do you put them next to each other and then go on to like the horizontal?
Yes, you can. You can do all the vertical first,
And
then all the horizontal. Or you can alternating become dilation, translation. That's fine. So dilation on the horizontal, dilation on the vertical, translation on the horizontal, translation. But that for me is a bit confusing. I always do all the dilation and all the horizontal, then all the vertical. It's easier for my brain to work with. Yeah. So -5. That means is, where should I move the -5? Y over, right? -5. So the factor of dilation is -5. That is a vertical dilation, right? If you want to say vertical dilation of -5, you can say it reflected on the y-axis, on the x-axis, then it translates. Then it dilates. The negative means reflections. Yeah, if you see that the reflections mean negative. Yes.
That's a lot more words.
Yes. And then you +4. That means you are moving it
To the left. Up.
Yes, because it's outside of the x
Yes.
square. So it translates up by 4 units. Okay, make sure you write the unit.
Translate.
Yes, translate up by 4 units. Or translate 4 units up. It doesn't matter. As long as your English is right. Oh, good? Yeah. Okay, and let's look at question 14. 14, you should have a cube instead of a square. X minus 5 cube. That's it. Yes, x minus 5 cube. Yes.
Cube.
Yeah, because I give you x cube and then I tap the square in there.
Yes.
So, want to talk about the vertical first? What? Yes, vertical dilation factor of 4. And then what else did you do to the vertical?
-1/2.
Yes, going down. Translate down.
Units.
Yeah. Okay, and then horizontal.
Translation.
Translate to the
Right.
right.
By 5.
Good. Right. Then the next question you can do at home. So then we are going to look at the really last page where you work kind of backward. Now I give you the image. The point after, remember the A we had? I do a translation and go to somewhere. Now I give you the somewhere. Where is the original point? Yes, you are working backward. Right. Since when we work forward, we do dilations, then we do translations.
So we
Now
do
you
Translations first.
yes. That's what we are going to do. That's the only difference. So for the first one, you have -2 and -8.
It's the same.
X is going to be the same. Good. X stay at -2. And then the Y, you have to move. Instead of -3, it go down. Now you need to move.
3.
Yes, you +3. You need to work opposite. Everything opposite. Yeah? So you have -8. And then you need to +3 to it. So it becomes -5. And then normally you times it by 4, right?
Divided by 4.
Now, yes, you divide it by 4. Yes, that's what you do. You do opposite of every single one. Plus become minus, minus become plus. The one later become first, the first become later. Yeah, opposite everywhere.
So now you're using equations again.
Okay, let's look at the x first. x plus 5, normally you shift it to the left. Now you need to move it to the right. So you move right by 5.
And then you have to divide.
Yes, the y divided by a half.
So many different things is happening. Okay.
Make sure you don't mess it up.
Divide by a half.
Yes.
Is that times by 2?
Yes, yes.
Okay.
So become minus 16. All your basic maths.
Okay.
Okay, this one, let's look at the x.
So it
Move
moves
it
to
to
the
the-
left by 2.
Right by 2,
Right.
right?
So then
Move it to the
Move
left.
to the left,
Left,
yeah.
yes. Move it to the left by 2. Good, good.
Minus 4.
Divide
Yes.
by 2.
Divided by,
Divide by times.
divide, it's
Divide by it's times by a half,
divided by a half.
which is divide by 2.
Yeah. No, no,
No,
no,
no,
no.
times by
No.
times by
No,
a half.
because the,
Because you usually divide it by a half.
No, you usually divided by a half.
So then
no,
you
wait,
times
wait,
by
wait,
a
wait,
half.
wait, wait. So the dilation for this would be a factor of half.
Yes,
Usually you times it by half, so
Yes.
they're dividing it by half,
Yes.
which is timesing by 2.
yes, you divided by a half.
Divide by a half.
Yes, yes, that means times it by 2. Mm.
So it's
Becomes
Minus 8.
minus 8.
Mm. Good.
and then
This one you move it.
Add it by add
Oh,
4.
no,
yes, because
Down,
down, so
down,
you
down,
up.
down.
No,
You move
Down,
it down by
down.
4. Yes, you opposite way.
Minus
Minus
12
12,
divided by 3.
and then you
Negative
divide it
By.
by
3.
1.
It's usually times it by negative 3.
Yes.
Times it by negative 3. Okay.
There's too much happening.
Okay, normally the 3 go under the y. That means you times it by minus 3. Now you
So now you
divide
divide
it
it.
by minus 3.
So it becomes 4.
Ah, yes, yes,
What are we doing?
yes. You are going to, first thing you minus 4 become minus 12. Then you divide it by minus 3.
Okay.
Yes.
Because you
Because
usually times
times
it by
by
negative
minus
3.
Mm. Don't flip the number, just change
Yeah.
the times to divide. Mm. That's why I said, I wish you remember earlier you said divide. I said don't,
Then
keep it as a time.
Yeah.
And because this one is going to be divide now.
Yeah.
Everything is divide.
Okay.
Opposite way. Yes. Mm.
Last one.
Last one. Pull out the 4 first. That's the first thing to do. Mm.
Moves to the left by 3.
Yes, going to the left by 3 and then divided by.
Divided by 1 over 4.
Good, because the factor is a quarter. Mm. Divided by a quarter. Good, good.
Okay.
Okay, this one, you need to move it up by 1 because it's minus 1. I heard you say 9. Mm.
And then times it divided by 3 on 2.
Yes, that's right. That's right. That's the way. Mm.
This sucks.
Oh, good? Yep.
Yes.
Yes. Okay. Now, your homework, I'm going to give you another paper, which is another dilation. It's the same idea, just do it all over.
Yeah.
Yeah. That's for you to practice on. Everything should be already in the other one. Okay, using the same method, don't forget it next week.
Yes, okay.
Right, then I'm going to talk a little bit on the stationary point.
Do you have any assessments left?
Yeah.
Oh, math.
I have the math one on Tuesday and then I have English.
Oh,
I have to do the multimodal. I don't know if you guys have that.
We have- we don't have any multimodal. Oh, we have one next term.
Yeah, we have ours this
What are we
time.
doing for the multimodal?
You're supposed to analyze 2 texts.
Ah.
Your classroom text and some
Wait,
other
what
related
text are you
text.
guys doing?
All the light we cannot see. That's the class we're doing.
Oh, wait. What?
There's also
Are
mention
you
of,
doing English advanced?
yeah.
Yeah.
So we also have mention of Venice and
Ah.
1984.
Yeah.
Those
we're
are the
doing
3
Merchant
texts that our school's doing.
We're doing Merchant of Venice, The Hours, and Mrs. Dalloway, and T.S. Eliot.
I don't know which poem we're doing yet.
But-
I think it's probably some other one there. So we started doing this Seamus Heaney. I don't know who the guy is.
Wait, who's all the light we cannot see by?
Anthony Doerr.
Is it?
It's a very good book.
Oh, okay.
Like actually, though.
That's
It's
good.
boring in the first half, but it's really good.
It's very good. It's boring.
Yeah, it's okay. It's boring in the first little bit, and then it gets really good.
Okay,
It's like really interesting.
that's really good.
Yeah.
We don't have any English assessments this year. We have it next year. But we've
Okay.
already got an
You'll suffer
assessment.
next year. We'll
Yeah,
suffer this
we'll
year.
have 2 assessments next year.
Yeah,
but-
because you got your assessment period as well.
Yeah. So that's gonna be so fun.
Yeah.
I'm so excited.
You don't sound excited. I hate English. English sucks.
I like English. Okay, so I used to do English Extension 1,
Uh-huh.
but then I dropped it because it's a lot of effort.
Yeah.
But it was really fun. Like,
Really?
because it was just you just talk about like a text, and you're like, yeah, this
You
guy's
just-
old. Like he's
Yeah.
not.
You just have to BS.
Yeah. But now it's like English advanced, so
Yeah.
so much fun. And much in Venice.
Yay. Yeah, I had my friends complaining about it a lot. Thank you.
Yeah. Right, so what we are going to go back is the calculus, stationary point. Right, so if I have any equations, so you can do f dash of x, of course, that is giving you the gradient, isn't it? That's what you have been working on. So 4x to the power 3. So if I have the gradient is positive, that means my line is going this way. My gradient is negative, that means my line is going this way. When the gradient is 0, for example, this one, the gradient is going to be 0. Agree? Yeah, those will be your turning point. So if the question wants you to find turning point, what you say is like at turning point, of course you cannot write TP, so f dash of x equal to 0. And then you will try to solve it. So you're going to have 4x cubed equal to 0, so of course x equal to 0. Because you are looking for point, you need the y as well. So if I sub it into here, f of 0 is going to give you 0. So therefore your turning point is going to be that. So far so good. Then the second question I'm going to ask you is determine the nature. The nature, that means whether it is a maximum point or a minimum point. Or the other turning point is going to be the cubic. So thinking about the cubic curve, you have it going this way, and then you have it going that way. Positive gradient, and this point in here, actually gradient is 0. So this turning point is called horizontal point of inflections. It's a big name, right? So if you have the turning point, that means you can decide whether this one is max, min, or HPI. So that is what your job is. In order to do that, first method you are going to learn is draw up the table of value, right? So the table of value, whatever the x is, go in the middle, right? And in here, you are going to have f dash of x. So of course, this is where we come from. F dash of 0 is going to be 0, isn't it? Because it's giving you 0 in here. Then you pick a point that is less than 0. For example, I can pick minus 1. Greater than 0, I can pick 1. So if I pick minus 1 into here, I'm going to get minus 4. 1 into here, I'm going to get 4. So that means your gradient in here is going to be going negative, going this way. And then it goes flatten out, and then it goes positive. So this is what your curve looks like. So if I need you to sketch this graph, you know this is a minimum point, isn't it? So therefore you can conclude your turning point is a minimum, or more precise, this is called local minimum. Local minimum point. Right. And in here, if I need you to sketch it, you are going to have a 0, 0 in here. That's a minimum point. That means your graph is going to go like that. Oh, good. Yes. So this is what you do in the really basic type questions. And now if I look at another equation, which is your equation number 2. So do you want to look at the equation 2? Do you think you're able to reproduce it at home? Or just quickly write it down first? Yes. When you try to think what you have to write, don't look at the board, see whether you can reproduce it.
Which
Yes,
means
stationary point.
zero.
Yeah, turning point, stationary point, they are mean the same thing. So first thing is differentiate it. Yeah. And I'm going to show you the second method next week what to do on determine the nature. Yes, this is the method number 1.
I think, yeah. 'Cause
Yeah. Have you been doing this one at school?
No, not at school, but
Yeah.
I think I've learned it somewhere.
Yeah.
And I don't know where. Like, we haven't done it this way, but it was some like, it was really complicated.
Okay.
Like, really stupid. And I was like, we're not going to learn this at school, so I didn't pay attention. And now we're doing it.
Okay, when I draw this part in here, something I will not, I want you to do is that make sure your line is kind of continuous. Don't do something like this. It doesn't mean anything. Yeah, so if I put my line in here, that means I can see the shape of it. Yeah. Nothing wrong with that, but except it doesn't indicate what you want to do. Yeah. Okay, and if you turn to the next page, I want you to do exactly the same thing with the other equations. You already know what it looks like. I just want you to, using the methods that you learned in here, you're able to find out the turning point. So let's try it all over again with the same methods you have.
Oh.
Negative,
It's not like
negative square is going to be positive. This one's going to be negative because they put in this.
Right.
Mm.
Oh yes.
Yes.
It's a cubic.
Yes, it's a cubic. Yes, it is a cubic.
Basics.
You all know it. So it becomes a cubic.
What was it called again? H something.
Horizontal point of
Point of
inflection.
inflection, right?
Yes, yes.
What's the vertical point of inflection though? Is there a vertical
No,
point of
there is no
inflection?
vertical point of inflections. Yes,
It's just
only horizontal point of inflections. Yeah. Yes, because at that point it's a horizontal.
And then if it was like a,
It's still horizontal.
if it was a parabola, then I was, I don't know. I'm not
Okay.
gonna try.
Now we have name. Now we have 3 names. You have the minimum point, you have maximum point, you have horizontal point of inflection. Now, so now I have introduced 2 more names. This one is concave down curve all the way to here. Somewhere, I do not know where at the moment. And this part in here is concave up. So where the concavity change, this one is the point of inflections. What does it different from this one? Horizontal point of inflections, or sometimes it's called stationary point of inflections. This is a stationary point. This one is not. The gradient is not 0 in here. The gradient is 0 in there. That is the difference. Okay, this one, yes, it's change from concave up in here. This is concave down. It changed concavity. That's why it's called point of inflection without the horizontal, because this one doesn't have horizontal gradient in there. Okay, makes sense? Be really clear with those 2 points. Right, and I think I will stop here. Let you take out these 3 points: maximum, minimum, horizontal point inflection, and point inflection. We are going to look at second differentiation next week. Yes. Okay. We are going to look at more concavity next week.
I don't know, because